Hello everyone. Welcome to chapter, or I should say module 4, and we're getting started with section 4.1. Before we start on this, I want to, just as a reminder, say that module 4, we are going to go through a bit more slowly than the first three because there are a lot of really important ideas here. So we'll be breaking it up over basically two modules. So we'll have module 4 part 1 and module 4 part 2. Related to that, some of these sections will be covered in multiple videos instead of having one video for the entire section. So for section 4.1, we're going to have probably 3 or 4 videos, probably a little bit shorter for most of them. So in this first one, we'll be looking at the first learning objective, derive chemical equations from narrative descriptions of chemical reactions. So let's go ahead and get started on that. You might remember towards the start of the semester, we discussed that we have different ways of representing things in chemistry. We have kind of the macroscopic view, so what would you see if you went in the lab and interacted with a chemical? We have what's going on at the molecular level, and then we have the symbolic representation. We're moving into really focusing on the symbolic representation, but before we do that, I want to start by making sure we understand what the symbolic representation is representing. So one of the things that we will be looking at with a chemical equation is what that means to have a chemical equation. It doesn't mean that there's this sort of alphabet soup that you rearrange by putting your spoon into the bowl. Although we kind of represent it in that way, and that's a good shorthand in terms of understanding how it happens. So what actually happens looks more like this at the molecular level. You have what looks like a random assortment of molecules, and then when the reaction is done, you have this other random assortment of some different molecules, and you might even in some cases have some of the same molecules. We're not showing that here. But that's the complexity that we're trying to simplify into something we call a chemical equation. So here we're showing a chemical equation, and I want to just walk through what this means. In the paragraph preceding this, I want to talk a little bit about this as well. It talks about, you could have this sentence. From this sentence, could you write a chemical equation? And the one thing I want to be clear about here, we haven't talked about methane. Methane is an organic molecule, so I wouldn't expect you to know when you see the word methane that means CH4 in this class. But for each of the other ones in here, you should be able to know that. So if they didn't put the O2 in parentheses here, you would know that oxygen molecules are O2, carbon dioxide molecules are CO2, water molecules are H2O. So just by reading that equation, you should be able to come up with this information. So let's talk about this information. So we have the formulas of the reactants on the left side of the equation. So the left side of the equation is showing what you start with. Okay, you start with reactants, in this case methane and oxygen. And then we have this arrow. The arrow here is not the same as an equal sign in a mathematical calculation, although we'll see in a way we do treat it that way to some extent, and we'll talk about why when we get to the next video. But the arrow is showing the passage of time. So over the passage of time, so we can say this arrow is showing us the direction of time. Over a period of time, you end up eventually with what you have over here. Okay, these are called the products. Okay, you start with reactants. over a period of time, you end up with products. When you have multiple reactants or multiple products, so here we have methane, oxygen as reactants, carbon dioxide, water as products. When we write the chemical equation, we separate it by using a plus sign. So a plus sign is just indicating we have this reactant and we have this reactant. So you're separating those out with the plus sign. Same thing on the product side. So one other thing that shows up in the chemical equation are some numbers that are in front of the substances in the reaction. These are called coefficients. So the 2 in front of the oxygen is a coefficient. Same thing for the 2 in front of the water. For the methane and the carbon dioxide, we're not writing it, but we assume they have a coefficient of 1. So if there's a 1, you don't have to write it. Similar to when we have a 1 and within the formula of a compound, we don't typically write it. So there's something distinct here between coefficients and within the compound we have a subscript. Okay, the 4 on the methane is a subscript. That is a different thing than a coefficient. Coefficient is telling you how many of that substance you have, whereas the subscript is telling you something about what that substance is made of. And I think we can see that more clearly when we look at the molecular level description of this reaction. So we have O2, each molecule has 2 oxygens, and there are 2 of them. So we have this distinct molecule and this distinct molecule. So they're separate molecules, this one and this one. Whereas with the CH4, you have 4 of the hydrogens that are part of the entire molecule. We only have 1 molecule here, but we have 2 here, we have 2 over here, we have 1 here of the carbon dioxide. Okay, so this is a way of showing a chemical equation. So be aware of what are reactants, what are products, what the plus sign and arrow sign indicate, and then what are coefficients. One thing, a little bit more with the coefficients. So we're showing here molecules on the molecular level. We could also talk about that on the macroscopic level. So we could say a mole of methane, 2 moles of oxygen, and that's typically how we'll be doing it. Because you can scale up by basically multiplying everything by Avogadro's number. In terms of actually looking at it and looking at a pictorial representation, it's easier to do that with molecules than with moles, obviously. But how we will use this will be typically on the level of moles. And then we're showing again here what that reaction mixture would probably actually look like. So this is the first part of section 4.1, and we'll be moving on to the next part, which will be on balancing equations here shortly.